Everyone, in this video I'm going to talk about another example of making use of simultaneous linear equations for comparing best buy analysis. Here is a situation. You have to compare two car rental companies, and this is what they are offering. So vendor X is offering a daily rate of $50 and he's charging cost per kilometer driving of the vehicle as 20 cents. The other vendor Y is charging you a daily rate of $60 and he's charging a cost of 15 cents per kilometer. Now again, I said anything that says daily rate, flat rate, that is your y-intercept straight away. Any word that is associated with the letter per, that should immediately indicate that is your slope or gradient or rate of change. All right, so these are all synonyms, and this is the key indicator that this is your slope or gradient. So now let's see how you can write the equations. So if let's call the cost, right, that is your y, and let's say the number of kilometers that they are driving, k, representing with the letter k, right? C is the cost, k is the kilometers. Let's us treat kilometers as your x and cost as your y. So everybody should be familiar with y equals mx plus c formula, right? The gradient intercept or slope intercept form of a linear line, linear relationship or a line. So let's see, let's call C of X as the vendor X cost, right? And then C of Y be the total daily cost for vendor Y. Okay, so just to make the difference. And in both cases, you are having K is the number of kilometers driven in a day. So now in the first situation, the cost should be written as 50 plus 20 cents per kilometer. Agreed? So we treated k as your x and c of x is your y. So y equals mx plus c. This is your c, y-intercept. Now for the second situation, it's the same thing. C of y, the cost for vendor y is $60, the flat, plus 0.15k. So the gradient is always with the letter, right? Your slope is always with the letter x, mx. So k of this value, so this is your gradient. All right. So now once you have these two equations, now you are trying to find a point of intersection or a break-even point, right? At that point, the x and y values should satisfy for both equations. So that is the one specific point where this equation and this equation of the line passes through. And so let's see, I can say since the y at that point is the same, I'm going to equate equation 1 to equation 2. Okay, so this is your equation 1 and this is your equation 2. So let's say then 50 plus 0.2k is equal to 60 plus 0.15k. Now you all should know how to solve for a variable, right, using your algebraic rules. The 5 golden rules you can check out again and review your knowledge on how to solve equations. So in that way, when you do that, so you're going to do minus 0.15k minus 0.15k. So you cross this out, minus 50 minus 50. So you have 0.05k equals 10. Then you divide both sides with 0.05, right? So 10 divided by 0.05, at this point, if you have calculators, type it in. It should be 200. Therefore, if you plan to drive 200 kilometers in a day, both vendors will charge the same total cost. This is to help you visualize cost comparison, traveling over distances, right? So let's do a table analysis of this. So let's create a table. So you do have kilometers, and then your y is total cost of vendor X and total cost of vendor Y. So if you're traveling or driving 100 kilometers, what happens in the first situation? The first situation, you just go back and substitute into the equations. So 50 plus 0.20 times 100. Okay, so in place of k, you are substituting these numbers. So when you substitute 200, you get 90. 300, you get 110. When you substitute 400 for K, you're getting 130 and so forth. Similarly, you're going to substitute 100 in equation 2, which is the vendor Y. So 60 plus 0.15 times 100. So that would be 60 plus 15. That would be 75. And then when it is 200, you would end up getting 90. When you're driving 300 kilometers, you're getting 105. So when you're driving 400 kilometers, you're getting $120. And then when you're driving 500 kilometers, you are ending up getting 135. So what's the conclusion by looking at the table? You can see that if your driving distance is less than 200 kilometers, right? So then it is advisable to stick with vendor X because his prices are 70 for 100 kilometers and up to 200 kilometers. Then you both end up being the same. It doesn't really matter. Both are 90-90. But as you keep increasing your distance of travel, right, as your kilometers are going up, vendor X is always a slightly on the higher margin. And then vendor Y, you can compare that there is a difference in the pricing. So what can we conclude? For the distances less than 200 kilometers, vendor X offers a cheaper rate. At 200 kilometers, both vendors charge the same amount. And we see that for distances greater than 200 kilometers, vendor Y becomes more economical, right? Economical means cheaper. Now, this analysis demonstrates how simultaneous equations can help us compare different car rental options based on varying daily rates and per kilometer charges. Now, this is another good example of linear modeling and getting to analyze best buy, right? Best buy analysis, where you can understand a break even point and then see which one is better, which one is economical, and you can do the cost comparisons. I hope this explanation is helpful. Thank you guys. Thank you for watching. Have a wonderful and blessed day. Bye bye.